Hello my friends, Uncle Misha is here and this is Inside Out Electronic channel, and we are looking today at TIC V700. This is 3-head tape deck. I got it relatively inexpensive, but I don't know what kind of condition it is. So as you see, it's pretty shiny. It's silver plate deck from TIC. And what other features it has? It has, as you see, 2 motors, logic transfer control, silent mechanism, 3-head system. Really cool, and actually I like pretty much this huge display of TIC, which actually also looks pretty detailed, especially in the in around 0 dB area. It's like 420247. It's a 2 dB step, so it's give you a chance to tweak your levels much more precisely. So it's standard stereo deck, nothing to rave about. It has, as I mentioned, 3 heads. One is like combinational record playback, one erase. It has 3 motors. One is real, one is capstan, and one is mechanism. So this thing has tape loading mechanized or motorized. It has automatic type selection. So as you see on the front panel, there is no type A button. And it has 2 only noise reduction systems, B and C, wow and flutter 0.06%, harmonic distortion 2.5, input 275 millivolt, and out and 0.34 microphone in half a volt line. It weighs 7.5 kilos and it was manufactured in 84. So well, it was first sold by TIC in 1982 for about, the price was about $500, but it was discontinued 2 years later in 84. This model is from 84. I don't know, nothing really special about this particular deck. The only thing, it has 2 older cousins, so V800X and I think V900X, which also included DBX, Dolby noise reduction system. And as you see over here, they looks like they share the same display, because in this particular light you can see DBX and DBX disc available right here, so which this deck does not have. Another cool thing, it has memory, CPS, it has 4-digit counter, linear counter, which actually shows you minutes and seconds, not just some generic numbers like, counter. So this is really cool. It can also, I think, scan for some pauses and rewind to next song. It has this feature. It has bias fine tune, which is actually pretty cool, and it also has a output which you able to adjust if you, for example, listening via your headphones, and obviously the backline output will be adjusted as well. The record level is right here, sliding controls. Again, I'm not sure, maybe those need some good cleanup. All those touch feather control looks pretty nice to me, and things like that. And obviously eject right now not gonna do anything because it is motorized. So if this motor is shot, we are SOL. So this is cool because this guy has a monitoring, because being 3-head, you can hear what you're recording on the tape right away while you're recording. It's pretty neat. So let's take a look on the back and see what's there, but I'm pretty sure it's going to be pretty bland and pretty simplistic. So here we are. It's just pretty plain back. Has 2 line in and line output. Its serial number is 80,107, and it is, I'm not even sure when it's made, doesn't say here. I think it made in 84, made in Japan, which is pretty cool. It is 34 watts. This is energy consumption of this beast. Under license of Star SA Brussels, Belgium. I don't know what's this about, this under license stuff. It's cool. Let's try to open this deck, okay? And then we power it up. I would like to take a look first to see if there is no anything like exploded inside the deck, any shorts, any bad connections, any kind of deterioration, which in this case, I would not try to turn it on. Rather, I would try to fix it before I turn it on, to see blown fuses, to see leaked capacitors. If I see something like that, I would have to think twice to actually turn it on.
Okay, so now I think we need to get a little bit closer to our subject right here. So we need to unscrew this bottom stuff right off here. Okay, so there's a whole bunch of self-toppers. Oh, it's cracked here. It's not that a big deal. It's probably would have to remove the front panel as well, so we're gonna just take it off right there. Oh, that's sad, but we can remanufacture this or glue it. Okay. Ta-da! Oh, cool. The board is like concaved over here, and this one as well. Why it's bowing? Like, it's just crazy. Look at those bodges. 2 capacitors right here, 1 capacitor right here, and the power supply side looks like. Interesting. Yeah. Okay, the belt. This belt looks like in okay shape. Okay, so in order to remove the back, I think I would need to unscrew those two. I'm gonna do them right now. This is, no, it's not self-topper, it's a proper one. M3. Okay, it's gone. So okay, I don't think I have to touch anything else on this side. There's another bodge over here. Not bodge, but like, is it made in Japan, I hope? Made in Japan, but it's just soldering job is like, could have been better. Yeah. A few bodges, like with another little bodge over here. But otherwise, everything is okay. What is this? It's another little board. Yeah, capacitors are like this. Okay, cool. Okay, anyways, I'm gonna capture some high-res photos of all this. Let me turn it upside down and see what else I have to take. Oh, it's hard. Catching everything, it's big and heavy. 7 kilos, guys. Okay. Oh, this cracked as well. Whew. People, come on. Huh, interesting. Not sure if I need to remove this front panel, but highly likely I have to. Okay, this is all. What else? Oh, 2 more right here. Okay. Each side. Whole bunch of self-toppers. Now what's awesome about all those self-toppers, they all the same size. You don't have to really think what goes where. Right. Oh, now? Okay. Oh, the whole thing comes... Oh, wow. Okay. I'm not even sure if I can show you all this. I'll try. Okay. Do I need to even pull this apart? Okay, okay, that have to be removed, I think. Okay, something to this extent. Okay, that's better. Holy smokes. What else is not letting me? Yeah, it's really hard to see what's going on. Okay, definitely this has to come out. Okay, this has to come out for sure. But there is something else. Something else is holding all this. And I'm not sure where it's going to. You know what? Wait. Maybe I'm wrong. Wait. Maybe I don't have to do this. Wait a second. Okay, so after poking around, I think I don't really have to remove the front over here. We can do something to this extent. So there is one screw. Oh my god. One screw right here, and there is one screw right here, and I think that's it. So let me... Unfortunately, I don't have the long enough screwdriver, but I have this perversion of a screwdriver. Oh my god. Why it's so complicated? Oh. Right. Wow. It's crazy. Okay, let's do something like that on this side. And someone already put some goop over the screw here. Okay, that was better. It's a tiny one. So what else? What else? Okay. I have to remove this. Not letting it go. Oh, I see. Oh, mamma mia. Okay. Okay. And these wires, what else is gonna be interfering? Okay, let's try to pull it through the front. Is it even possible? No, it won't be possible. Oh, these guys. No, because I will cut these guys. Oh, yeah, it sucks. Okay. They are connected. No, I won't be able to do so. Look at this beautiful, oh, I'll show you. Okay, so I think the only possibility to pull this Mac tape mech through the front, and I have to make sure you're not chopping off these wires with these metal plates. So you have to like lift it right here and try to push through. So yeah, it's sort of kind of not easy job, and there is nothing to grab on, so you don't want to like break anything. Wow, sort of amazing that it actually okay, what's tangled here? Heads. Whew. Wow. How could I? Okay, I have to cut this one. I have tons of these. I'm gonna put them back as long as I'm not damaging wires. And also I'm recording all that, so I'm gonna put them in the right spots. Okay, so now I free those wires and these. Okay, that's so much better. Okay, so now that's it. That's a stretch to the max, I think. Okay. Curious, like what wires go where, because it's not clear at all. So this side of the head goes in here. Let's just yank this, right? Disconnected. So that side of the head goes in here. I assume one of the recording, one of the playback connectors. Okay, I probably record P611, and this one is erase head. Okay, all right. So that, but that's not over yet. We have two more. So green one. And yellow. Wow, it's really hard. This one is tough. They just probably should have done it before pulling the mech out, because now it's really hard holding it and doing all this. Okay, I'm gonna just hang it right here. Have to use some leverage to actually pull this out. Whoa. This is crazy. This is crazy, but at the same time it's... Look at this beauty. That's it. The tape mech is out. Unbelievable. Oh my god. Alright, so now when we have our tape mechanism out, we can take a look what's going on here. So as you see, it has only two control connectors. So those are a bunch of wires, 6 over here and about 10 over here. Then we have the heads connectors. So record, playback and erase heads. This is amazing. So because this is first ever a tape deck when I was able to completely pull out the tape mechanism, and it looks like, from what I see, it's quite easily serviceable. So for example, if you want to remove capstan, I think I need to unscrew 1, 2, it. and I don't know, maybe those two over here as well. Yeah, it's super easy, and I'm probably gonna remove caps and I'm gonna clean it up and things like that. So there is a real motor and there is a Mac motor. So what else we see here? So there is also some wires coming on this way, and there is a little board over there. I see. Let me pull this out and see what I gonna get there. It's really hard. Okay, on this side. So looks like we have some. Over there we have some wheels on one reel or another wheel, and those reels have holes. And from what I gather, this is some sort of feedback loop, because those lights, there is a light, I think there is a little light pipes, and they actually connect with those wheels over there. It's really hard to see. Maybe I have to crank up the brightness. Okay, I crank up the brightness, and probably still hard to see. Okay, those wheels, they have little holes, so probably some sort of feedback mechanism to you know, to see if wheels are spinning, or maybe even measure the speed. There is a little light over there on top, like you see this light right here. Okay, so this is supposed to shine inside this light pipe. This is pretty cool. So Tape Mac is obviously driven by this motor over here, by this motor, right? This. Not sure if this is original belt, but it looks weird. Never seen actually white belts. Maybe someone just used some rubber band from the groceries. But it indeed it works. So Mac is working. So this is capstan wheel over here. It's huge, it's massive, and the belt, this seems to be okay. This capstan wheel is a bit wibbly wobbly. I'm not sure if this is okay. Sort of. Oh, okay, so this plasticky retention thingy is springy, so maybe that's okay, because that's not supposed to be driven like this, I guess. And it's metal, and it's relatively clean. Like, actually belt is okay as well, so I'm not sure if we're gonna touch that. Maybe I would like to lubricate. Maybe I'll take it off and lubricate, just in case. Yeah. Okay, so we have all this. So what else we can see here? So yeah, there is a probably over here. It's still really hard to see, but there is a idler, which actually okay, this idler, it's idler wheel. It's either connected to this wheel, I guess, for rewind, and for fast forward it to be connected to this wheel. I'm not sure what's the condition of it. It's really hard to tell, but it looks like actually pretty good condition, and it's clean. And on this side you can see that the I don't know, take up reel, I guess, because it's gonna take up the tape. This take up reel is actually in fine condition, so yeah, it's not too bad. All right, so I think in order to close it, I have to return this in certain place, and it's gonna latch. So cool. Oh, okay, so we have a little light. I don't know how it did pull out that easily. So, well, oh yeah, okay. Yeah, no, I'm not sure if zoom can. That's a focus, it's not zoom. Okay, so let's take a little bit closer. So over here we have this light guide or something. So this little lamp goes in here. Okay, so this little lamp goes in here. And I guess it's gonna shine light also on the over here, and in those light pipes I already tried to show. So I guess these wires are some sort of sensors, optical sensors, because there is a little PCB which you can see. Hope you see it right there. So it's a little PCB, probably with some sort of sensors, or you know, photodiodes or phototransistors. So there's also two sets of contacts over here. So two contacts for a normal tape and like a record mode, and two more right here. Okay, let me show what these guys right here for the metal and chrome. So this thing has auto select. So yeah, Looks like one of them is constantly on, so I'm not sure what that's supposed to mean. This one. Is it constantly on? Have to probe it with multimeter. Interesting. So metal is constantly on. I'm not sure if that's how it's supposed to be. All right, so I'm not sure if we're gonna disassemble anything right here. So everything seems to be in a good nick. What I have to do is a clean up. Like for example, clean up this roller, clean up the heads, and clean up inside the tape mechanism. So I'm gonna do that off camera. So after some deliberation, I decided actually to remove capstan and try to lubricate it, because I noticed it has this kind of grindy noises. Not grindy, it's a rubbing noises. So I'm gonna take no one won't be able to help me to take this assembly off. And oh, it's even what? Okay, it's even easier than I thought. It's pretty much out. Let's try to use the screwdriver. Super easy to get to capstan belt. Super easy. Okay, what's going on here? This push thingy. And the wire is, you can, okay, so here's our capstan wheel, and I try to remove it. It's really long shaft. Shit, this wire is. Okay, that's easier. Here we are. This is our capstan. So I can clean this up, but it's actually. So here's our capstan. It looks pretty clean. A little bit dry grease here, which is gonna be cleaned up and re-greased. That's easy peasy. Yeah, let's do it. This is a little. Also, I will examine this belt. Super tiny belt for my, liking. It's like pretty tiny. I'm gonna measure it also. By the way, I'm gonna measure it for people, for the future generation. So we're gonna clean this up. Yeah, it's actually pretty clean. So surface here is very nice. Very nice. So I'm gonna clean up this as well. And clean up this. It's not too bad. It's our capstan. Okay, let's put it here. Let's take a look at the belt. It's a really thin belt. Look, what? How can it possible to be that thin? So here's our calipers, and let's try to measure this belt. Well, as much as I can do that because of the thickness. Something like that. It's 110, so it's going to be 220, 110 millimeters. This belt by 2. Then let's take a cross section. It's 3 millimeters. Again, I'm not sure if this one is original though. And 0.55 is the thickness. One more time, 0.55, 55. Almost half a millimeter is the thickness. Okay, this is good. I'm also gonna clean this up, or maybe even use gloves not to leave any kind of, fingerprints and stuff on this. Also, I will apply some silicone grease over here. I just noticed something. I noticed some residue over here and over here, so which tells me that this belt was actually replaced, because this is leftovers of previous belt. So yeah, clearly that was a replacement belt. So yeah, our favorite silicone grease over here. Let's take a little bit of it and plop it right here. This definitely never gonna harden. All right, good. Now I'm gonna assemble it all together, and do I have to? How this? Oh yeah, this is how it goes. Not gonna touch that, not gonna apply any grease right there. Although I'm also gonna take a look if there's any places when I have to apply some grease, but from what I see, it's not that many. So maybe apply some grease right here. Silicone lubricant right here. But I mean, I think it's necessary. A little bit over here. That's it. I think I found a piece of old square profile belt. Oh wow, so that clearly was over here on this pulley. Yeah, look at this. It's still goop. Like I have to dispose it, not to get it all over everything. Ugh, we're gonna. Oh, I have a solution for that. So now wearing my gloves, not to produce any more fingerprints. This is really awkward here. All right. That spins nicely. Just put this contraption back where it's supposed to be. Oops, let's not forget about belt. Okay. Also not forget about this device as well. No, I don't think I've done it properly. Okay, just like this. Where's the... Oh, where does this came from? Oopsies. What's going on? Oh, it's a bronze bushing. Oh, cool. Okay, that's so you'll put this back where it's supposed to be in a moment. Okay, so now I assemble this little screw. This is the only one screw which holding this for now, and the second screw is right here. So, but that's gonna be attached when we're gonna attach it to the chassis. Alright, so I have installed the belt. I'm using this sort of a hooked, I don't know how to say it, tool. It's a very nice set I bought like ages ago. There are a few more other different hooks, and this is very handy. Sometimes you need different angles on depending on how easy it is to reach things. So now we have to put this bushing back on. Tweezers would be a good idea here. Nice. Again, I'm not sure how deep it's supposed to be. So this little guy goes back on. Okay. So let's see how it spins now. I don't like this noise actually. When I spin it like this, It's like a little grindy noise. I'm not sure where it's coming from. So now when we have assembled everything back in place, so let's try to connect to the deck and see if we improved anything, right? Okay, so now we have to connect everything right here where it's supposed to be. Oh, by the way, this is, look at this. So if you are doing something and this is connected to the mains, you're gonna be entitled to the surprise, because if you're gonna touch anything here, you're gonna be jolted. Believe me. Okay, that was easy. Okay, now we have to connect some heads. Maybe not connect them right now. Let's see if the Mac is operating before it's actually playing with heads and stuff. Luckily those wires are pretty long. Alright. So now what we have to do, power it up and try to play something and see if we improved anything. Oh, the main thing to figure out why it actually doesn't play only for a split second. So we're gonna take a look what's actually engaging, because looks like belts are completely fine. So belts are not the issue. There is nothing stuck in the mechanism. So we have to figure out this might have been electronic. So look at this, some goop right here. Might have been some electronical problem. All right, guys. So we have our tape mechanism is propped right here on this sort of bridge connected to the board. The heads are not connected. So let's try to power it up. Again, when we are powering up, we're gonna make sure this thing is you're not gonna touch here. Make sure it's not gonna touch here, because you can shock yourself pretty badly. I need to address this situation and probably think about some kind of contraption container, or maybe even 3D print something which is completely gonna wrap all this in 3D printed housing made of PETG or something to this extent, just to make sure it's not gonna kill or jolt anyone else or me, whatever. Okay, let's just power it up. Alright, so it was just making buzzing noises and it did power it up. It's interesting, just noticed that this little light is actually not working. I'm curious. If this light is not working, I think I need the tape. You see, this light is not working. Maybe this little light bulb is critical to make sure. Oh my god, this is probably my problem. Let me think about something. So this is my problem. If this little light is not working, there is no feedback, and the system doesn't know. It try to rotate, but it doesn't know that actually it's actually spinning. It doesn't really know that those two are spinning for sure. So that's why it shuts it off, because it doesn't know that. Very interesting. So clearly I do not have in my household this tiny little bulb. So let's just measure. First of all, figure out where it is connected. Okay, that was stupid of me. So it looks like it is connected to pins 16 and 17. So it is connected right here. Let's just measure some voltages. Okay, how can I do it and show you this at the same time? We have 12.45, 12.5 volt. 12.5 volt. Okay, so 12.5 volt would require So the only thing I can replace it with is LED. I have pretty bright blue LED, which I can shove it here. And why I like blue, because I think, yeah, because, well, the screen is blue, the blue bezel over here, I'm not sure if it's lightning or not, don't remember. Does it have lights? No, I don't think so. Anyways, I don't have any other blue LEDs anyways, and let's first try to experiment if this thing gonna help or not. So let me MacGyver something and I'll be back with you. Okay, thanks to the breadboard, I MacGyver something like this. So this is a blue LED, and this is a 575 ohm resistor, and because we have 12.5 volt, the current we have running through this system is 12 milliamps. So this resistor is actually at borderline the heat dissipation. It's actually warm, but I think 125 milliwatt, it's about where it is right now. So we're not exceeding power dissipation of this resistor. If this is gonna be, I actually can reduce it because I think this LED is fairly bright, so I can reduce it to, let's say, 750 ohms or maybe even 1 kilo ohm, but like whatever. This is, I just grabbed the first resistor, and 11 milliamp, it's actually pretty decent. It's really low current, so I'm gonna just try to plop this guy right straight here. Okay, let me show you how, like, I probably need to use something else to show you. Let me use my phone. I'm gonna show you how it looks like. Okay, this is what we have. So this is how front of the cassette deck or cassette tape mechanism look like, and this how I plop it right down there. So this is the blue glow. Yeah, you see, I hope. Okay, so now is moment of, no, it looks kind of weird, but it's probably gonna work. The only difference because LED has the lens, focusing lens, and this little light bulb was omnidirectional, so hope that's not gonna mess up operation of this thing. But let's give it a shot first. Very interesting. It is working. So our little LED hack is actually does something. The only what I don't like this, I'm not sure if you hear it, this kind of noise. Something rubbing somewhere, and it's not good for the flow and flutter, obviously. Have to investigate that. I'm afraid. Wait, is this? Yeah. How about forward and rewind? Seems like it's working as well, so I have to MacGyver something right there instead of this little LED bulb. Yeah, I don't like this noise. Need to investigate that. Oh, cool. Okay, take a look at this. So I have installed it. This is my contraption. Yes, there is a hanging resistors right here. So I connected it to the back side of the PCB. So this is all good and dandy. So that's all gonna be like this. My LED is installed right there. And so let's give it a shot to play something. Oopsies. What's going on? Alright, so finally I was able to figure out how to position this LED properly. Turned out to be because of the LED lens and a crystal, not in every position it was actually working properly. So now I had to just spin it like this way, then turn it like this, then turn it like this, in order to actually find the right position when actually it works with the light pipes. So now let's give it a try, because still not 100% sold on it, so let's see what's happening here.
I don't like that. Okay, well, I guess that's not over yet. But maybe this is the tape itself. Let's me take better tape. Here is my new old stock. Well, it's already recorded. Fuji DR2. Let's see how that's gonna work. Clearly. Clearly. Clearly it's not a problem with the cassette, so cassette is fine. That's a problem with the mechanism. Right, so it's not over yet. Okay, let's try to clean up rollers. Do have access to this side. I think we have something. The only thing is counter doesn't work. I'm not sure what's going on there. But it plays something. It plays something. Play very high. I'm not sure why it's so high. Maybe level is crazy. But yeah, but counter doesn't work. Alright, my friends, you probably see my reflection right there in this shiny kind of a front panel. Even clearly we have progress here, so take a look. So it plays, it actually plays well, level is normal, tape detection works, a real-time counter works. The only thing what's not working, this sort of counter, and I'm not sure why. Potentially maybe there is a issue with the LED I have installed, maybe it's not good light source. I don't have little light bulbs to actually give it a shot. And here's some music playing. I don't know where is the... Let me crank it up. It's not too bad. Well, seems to be where I was. This is my recording on Fuji DR2 from one of my other demo cassette players, and it seems to be doing pretty well. Button works, for example, the monitor source, clearly it's working, so now it displays source, tape. Yeah, look at this big and beautiful display. The only culprit actually bugs me that the counter which is not working. Yeah, of course this, I don't even know what the heck that's supposed to mean. This counter works fine, it's just okay, but another thing which is not working, for example, if you stop and rewind, it does nothing. If you go forward, it does nothing. I think technically it's supposed to count forward and backward, but meh, doesn't really work. pause working. Yeah, LEDs working as well here under the slides. So yeah, I think it's working fine. A few things I have to do. Number one is actually run my tape, level tape and speed tape and see where we are, and also maybe azimuth tape, but I don't really trust it that much. So with speed tape I will have to use this oscilloscope and level tape probably as well, just to see, but level would be checked by over here. Actually, level tape I probably would have to do through the service manual. Here is my 0 dB level calibration tape and see what we get. Wow, it's so much higher. It's +4. Okay, well, that's something to be adjusted. Let's try another side. I don't know, sure, maybe there is an issue with azimuth or something. No, it's clearly not, but it's reading a little bit different on the other side. Alright guys, just done speed calibration. Here's our speed calibration tape, and speed is pretty good. So 3.115 and thereabout. Only, as you see, there is an imbalance between two channels, so we have to address that. I think guys, I'm gonna wrap up for now. This video already very long, so I'm gonna do another video when I'm gonna show operational unit completely tuned up. And for now, thank you guys for watching, and see you next time in another episode of Inside Out Electronic. Stay safe and ciao.